recording. Okay, so yes, so what you have for this week is the following. By the way, how was it? Do you have any comments related to the lab number 1, the grading? If you don't have comments, I do have some comments. Please, in the following lab, starting lab 3, try to submit one file. Many students are submitting the lab report along with image 1, image 2, image 3, maybe file 1 for Excel, file 2. Don't do that. This will not affect your grade, definitely. It's only you training yourself to submit only one file for the midterm eventually. So the lab report has to be one single lab report where you insert all your images inside. Okay, I suppose most of everybody knows how to do this. This is one comment. Another comment, some students, and I'm talking about only 20% of your class, when you send me a document, usually all the pictures are modified. I don't know why. It could be because of Blackboard. This is one reason. It could be my computer, your computer. So the best way is to convert your document to PDF before uploading. Okay, this is my second comment. My third, I'm getting many attempts of the same file, which is okay, but usually I check the second file, is it the same or not, because I have to submit a grade for each attempt, and my Blackboard will take the highest grade. So maybe you're submitting many attempts by mistake. Maybe it was only lab 1 because you were not sure it was uploading. It's okay. All right, I'm just telling you some observation. I don't have anything else to say, only these 3. Do you have any comment concerning lab 1?
I have something.
Yes, please. I would love to hear you.
My grade is not showing, even though I submitted the lab, but it says it's grading.
So, Chris Mdawar, I want us really, I believe this is urgent. So, Chris, let me go to your class. Maybe this is not your class. I really want to make sure everything is well and not postpone this. So I believe I want to give this a very high priority at the moment, because if we are on track, we can move fast. Otherwise, we will have confusion. Okay, I would go to the grade center, check the assignment. I'm sorry I'm doing that on public, but nothing will show really. One tiny grade is not a big deal, I suppose. So Chris, let me show you your status on my screen. Okay, Chris, so far, your name, are you Christopher?
Yes, my name is Christopher.
Okay, so okay, I can see the first grade, I don't see the second attempt. Okay, so are you saying, Christopher, that your problem is fine? So lab 2 is not submitted yet, and you have, I gave you extra time due to request.
I submitted today, but I was checking because my grade wasn't showing on Blackboard, that's why.
Now it's showing or not?
Yes.
Okay.
Yeah, wait, let me check again. Because it's showing here with you, so I think it will show with me now.
Yeah, if you're not trusting, okay, James is telling us that he will join in a moment. So if you guys having any issue on Blackboard, let me know immediately. I need to know to be able to help you. I know Blackboard is functioning 99% perfectly well, but the 1%.
Okay, it's showing now. Okay. Thank you.
I think it's slow in a way, because sometimes I had an issue with Ramza last week, or maybe somebody else. He submitted the work, but it shows for me uploaded but not submitted, and it went there for like many hours. I was waiting for him, and he was and everything was fine from his side. So I think Blackboard is slow. I hope this, and we don't have any other issue. So now you guys shared your issues with lab 1. Lab 2, are you having difficulties? You asked for extra time and I changed the deadline. Do you have any issue? Yes, Anthony, would you want to say something? So Anthony has an issue. What is it?
Doctor, it's mostly with part 1 كتير خبص معي. So we can talk about it بالآخر or now, okay, as you wish.
Yes, I suppose your issue is not, you're not alone, because many students may have the same difficulty. By the way, this is your manual. So let me give you some tips, because usually I know what mistakes you do. Fill in the table, it's already done for you. Plot, this is easy, I suppose. You just need to calculate 1/d and make sure you have a good appropriate unit using linear regression. So you do linear regression on Excel, you get the slope. You will struggle with the unit because you will have the pico or nanofarad, I can't remember, and millimeter to the -1. So your slope will have a weird unit and you will struggle with this probably. So you will come up with a slope, the unit will bother you. You will find epsilon 0 from your slope, and I suppose you know how to find epsilon 0 from the slope, right? Right, Anthony?
Yes, epsilon 0 from the slope,
but,
yes.
Yeah, but if you're struggling with the unit of the slope, the unit for epsilon 0 will end up being wrong, which is okay. You can go over it and try to fix it. Done with epsilon 0. Now the error. To find the error on the slope, you have to use the equation or the line list, and I'm gonna ask you about the line list in a moment. And then you have to find the error on epsilon 0 doing propagation of error. هون بسيط صح؟
Yes, exactly. Sorry, Thomas.
How can I help you? Maybe I can try to show you how it would look like. I know that slope is epsilon 0 times A. So I'm gonna call it S to be equal to epsilon 0 times A. Maybe show you the derivatives, I don't know. This is slow because of the recording. So to find the error on epsilon 0, I'm gonna do the derivative of, all right, so the epsilon 0, maybe if I write slowly, it's not gonna flutter like this. So S divided by A, that's the function, right? Okay, so I'm gonna do the derivative of epsilon 0 with respect to A, which is S over A squared, and then do the derivative of epsilon 0 with respect to S, which is 1 over A. And here you have to be careful because you need the error on A. خبصت الerror on A ولا مش الحال؟ I think
لا الerror on A ما طلعت معي كنت عم
Okay, A is pi r squared or pi d squared over 4, and you have the error on D. So you do the derivative, which is 2 pi d over 4, which is pi d over 2, and you do the error on A. I think it's a very long process, but not a difficult one. It is a long process though. So if you grab an A4 paper and write it neatly, step by step, repeat everything, you will be okay. And now that you have one extra day to submit, I think, unless you're having difficulty on a level of how to do the derivative of S over A, like here, I need to help you. Okay, and now how do we type it all? Try to type not every single step, like brief it out, but have it on a paper first. All right, Anthony? All right, somebody's asking me something.
Is it fine if I submit a photo of my work?
No, we need it
copy
typed.
paste it.
Listen, we need it typed, and I'm giving you the opportunity not to type it all, like type some of it. Okay, but step number 1, solve it well on a paper. Then type some of it. Okay, no need to show everything. Like only the method and the final answer.
All right.
Can we try this? And I have some good news. This is the only long lab report. Like later on, especially now lab 3, it's gonna be easy. Lab 4 is gonna be a baby lab report. Really easy. Okay, so don't get frustrated. And remember, this is the only difficult and long lab report, if I'm not wrong. Okay.
Sorry, doctor.
Lahza, Ryan is asking me something. We consider in the table 1 over D or 1.00 D. All right, listen, 1 is not a measurement. It's only to say it's the inverse. Okay, which means don't consider the 1 in your significant figure analysis. So 1 is like half, it's like pi, is like square root, it's like a function, okay? So we show the equation, not the details. You don't have to show all the details, Chris. Jean, you were talking to me, right? No, not Jean.
Me, Joe.
Joe, yes, Joe.
Doctor, I have just 2 questions for this lab report.
Yes, please.
The first one, for the residential value of the K, when we have to find the theoretical value, it's a range or it's a specific value?
All right, so let me tell you something. Plastic when they tell you this is plastic, this is not enough information because you have 1 million type of plastic. And as you can see, the question is not graded. It's like a bonus question. So try to find something online and discuss your answer. Is it within the range of what you can find? You see, I know a lot of students were asking about this question, and I do believe this question was...
So no percentage error. Okay.
Try to discuss as much as you can, as much as what you find. It depends on what you find online, okay? So maybe you can find something, you can change the question. You can change the question and say, I found K equal to this much, very close to my answer. So this type of plastic could be, I don't know, some specific plastic, you know? So just discuss your answer. Yes, ask me, Joe.
Yes.
What other question?
For graph, I kept the unit as it is, yani PS and picoF and centimeters.
Yes, you can do that as long as it's not bothering you and as long as you don't do mistakes as you go down. Because sometimes you have to be careful about your units. Here you don't have an issue because you don't have a combined unit. Like it's gonna be always farad and meters. It's not like you have joules coming up or something, you know? So once you don't have a combined unit like newtons or joules, you can keep track of your units and no need to use SI units. If you're not sure about it, you don't have confidence, use SI units just to be confident, but you don't have to.
Okay. And doctor, for the calculation, is it okay if you use the rounded values? It's easier for me. And for example, if I found that the area is 272 plus minus 1, I can use in the calculation 272.
Yes,
the one with rounding plus minus.
Yeah, you are supposed to round the area first, then do the calculations. Yes, of course. Usually we don't round for every step, but for major answers,
we can use them.
Area,
okay, thank you.
Yeah, we need to round. All right, so I can see that you're basically tired from this lab report, and I totally feel you. If you keep on having questions, please do ask.
Doctor, questions, if it's okay.
Say it again.
I have 2 more questions, if it's okay.
Please ask.
So in part C, we have to find the percentage error for each one, right?
Part C, yes. So it will be great if you can open another column and write percentage difference. The first 3 you cannot do it because there's no calculated. It's basically for those.
Okay, and for part D, finally, what do we use as this? From where can we find the case that we should compare it to?
Then they want you to find the dielectric and that's it. They don't want you to compare to anything. They want you to try to tell what is the material inside the cable.
Yes, how K is.
Yes, so you find K and you go online and try to check what K could be. Can you tell? Maybe you cannot tell. Or maybe you can estimate, I don't know. Or maybe you can check RG58 coaxial cable online and maybe see what's inside and see if it's close to your value. So again, it's a discussion. Okay, just show your answers.
And they ask, just the part before it, I'm sorry, I mean the cable 1 plus cable 2, do we say that it has two adapters?
Actually, they do have 2 adapters, but to make your life easy, we only gave you only one, ignoring the other one. So you can ignore the other one, although experimentally we did not, but just to make your life easy, and I'm sorry for this confusion. So just consider you have 1 adapter.
Okay, got it. Thank you.
All right. One second, Chris. And number 4, is it comparison between 2 Ks or just 1 K? It's up to you actually, Chris. Check what you have and discuss what you have. All right? Why am I saying this? Because what if the other cable is not RG58, although both should be? I remember through the experiment, they had the same thickness, but different length maybe. Discuss your answer. Let me keep it as an open answer. Remember, it's a lab report. It's not like you have a solution to present and the final answer to give. So it's mainly discussion. Yes, Michelle, was that you asking or Maria?
It was me, Maria.
Yes, Maria.
So for number 4, I got 2K and I got 2 materials for the dielectric. They turned out to be different.
Yeah, why not? So these are your findings. Okay? Yeah, why not?
Okay, thank you.
All right. Any more questions for lab 2? All right, concerning lab 3, it's about resistance and resistivity. So we need to discuss Ohm's law. Anybody remembers what Ohm's law is?
It's V equal Ri.
Okay, it's delta V, the potential difference between 2 points, to be equal to Ri. R is the resistance between 2 points. It could be the equivalent resistance. And I is the current flowing through your circuit. Okay, so, or through the branch you're considering. So as you can see, this is really basic. It's a basic experiment. Did you start with potential difference equals Ri and Ohm's law and maybe ohmic devices in the course?
We take the course in summer.
Yes, nobody's taking the course right now.
I am, but we did not start yet.
Okay, maybe you're still tackling potential, just potential, not yet circuits.
We should be starting tomorrow, though.
Yeah. Okay. Awesome. So this is like a warm up for you, or like a review for you. So now they're telling you if you have a series configuration, you simply add the resistance, and you all know this since grade 9. And if you have the parallel combination, you add the inverse to be equal to the inverse. By the way, I hate using inverse. I'd rather use r to the -1. You do have calculators, and this will make your life so much faster, unless you have an unknown to solve for. And this is important to see. This is R of a certain conductor, where rho is the resistivity of the conductor, L is the length, and A is the area. Which area? The cross-sectional area. Okay? I'm considering if I will ever use this one in the lab report. I'm not sure. Okay, now let me show you the lab report so you see how to behave, like what to expect, and maybe watch the video and I can leave you. All right, as easy as that. You will be given a resistor of 10 ohms. I will show you the board in a moment. You will use Data Studio. Data Studio will directly give you different V's, different I in a plot. So you will have V versus I, okay? It will definitely be a straight line passing through the origin because we're discussing ohmic devices, in other words, resistances. Miss Jessie, myself, will take different points on the line and I will give you the coordinates. Like those, you will be given the coordinates. Expect a table of measurements from my side, okay? Then I will repeat the experiment with 33 ohms. Calculate the experimental value of the resistance for each set of values. Like you take V and I, find R. You take V and I, find R. So please do not do linear regression, do not plot. They want you to do for each set of values. Then they say find the average. So the point is for you to train yourself doing averages, along with the root mean square. So in this lab, we focus data analysis, average root mean square. How do we do root mean square? Please use your calculators. It's the fastest way. If you don't know how, go back to the video, how to go into function using the calculator. If your calculator is different, please let me know and consider this week to learn how to use your calculator for RMS. Compare the nominal value, compare it, which means your average, to the nominal value. This is the nominal value or what's written on it, and your average, you already have it. Compare meaning percentage difference. Comment on the sources of errors. It means list at least 3 reasons why you have them not close. If the percentage error is below 5%, you can say accurate. Otherwise, you can say not accurate. You can discuss precision if you want by comparing with the root mean square. It's up to you. They never asked for precision though. And try to give 3 sources of errors, okay? If you need help with sources of errors while watching the video and considering the experimental procedure, maybe you can have some insight. Then in the next section, you connect the resistors, I mean 10 ohms and 33 ohms in series. You repeat, like you will get a similar graph with a different slope. I give you the values and you answer the questions, average, unit mean square, compare sources of errors. You may end up with the same sources of errors. You just can say same answer as above, or maybe add one reason due to the extra procedure step you did. All right, so now non-ohmic devices. For this case, you will be given a bulb. All right, and you will do exactly the same procedure like I did on the 10 ohms on the bulb. But you will change the voltage in two cases. Slowly with a frequency less than 1 hertz, or fast with a frequency above 50 hertz. And you will observe two different behaviors. It will all be seen on the video. One behavior is an ohmic device behavior, like linear relationship. And another behavior, you will see a curve. All right? First question is, this is for low frequency, less than 1 hertz. You will fill in the table. I will do the work for you. Your job is to come up with the errors. It's a digital measuring tool because you see it in digits, so it's easy to find the error on the measurements. Now you calculate R, and how do you find the error on R? It has to be propagation of error because it's a calculated value. You will do it for every set of measurements, okay? You will see if R is a constant or a variable. They ask you what you can conclude because of the change in resistance. You see R is different. So you have to conclude, is it ohmic or not? Easy. Sketch, the sketch you take, okay, from the video you can see the graph. Your job is to show the shape with a pencil, like draw with a pencil how the shape looked like. Okay, where do you get the curve from? From the video. Okay, then they ask what would be the shape if we use 50 hertz. In the video I used 50 hertz and I showed how the shape would be. What conclusion can you draw? Okay, we're done, like here we're done with the non-ohmic device. Question number 14 is extra. They gave you an alloy, okay? They gave you some values and they want you to discuss if it's ohmic device or not. Like this is some extra question just to wrap up the lab report, okay? It's not difficult, you can do it, use any method you want, okay? We finished it? What do you mean, Chris? Like we're just done? Not yet? Oh yeah, you're talking about the course. Okay. Now let me go and check the video and move with it quickly so I don't take a lot of your time. The video should be under raw recording LAU, maybe day 2. Yes, it's one video and it's not long. Let me check the length. I always like to know the length of the video before watching it. I don't know about you. It says 9 minutes. I will definitely go fast on it.
Hello, I will introduce resistance and resistivity experiment.
Okay, I want to show you the board. Wait.
The equipment needed, you would need the RLC circuit board.
Okay, there's something, I think there's a, okay, this one.
You only need 2 resistors and the bulb.
All right, do you see? So this is resistant 10 ohms, this is 33 ohms, and this is the bulb I'm talking about. Everything else I'm not gonna use, all right? But I explain at the beginning what each represent just for you to have an idea, because unfortunately you cannot go to the lab, and I really want you to feel what's happening, you know, to have the tiniest experiment, the tiniest experience, as if you are on campus. So I'm gonna show you only the first one. I will repeat for the second one. You can watch it later though.
The thing you do is the following. You go into your desktop, Modern Physics, the folder. You have a file ready for you. It's called ohmic device. You click on it and you wait a second for capsule to open. Yeah, this is already something, so let me delete.
So this is all the recordings.
And to start with a blank new document. All right?
By the way, when you go on YouTube, if the resolution is low, make sure you go on high resolution, because sometimes you have to read something out of the video or do some observations.
Now the connections. You need to connect the terminal of your output from the Pasco Universal Interface to the SCR board. Connect it first to my first resistor. So this is the first terminal and this is the second terminal of the resistor.
So the circuit is super easy. Just let's consider this battery and R, and that's it, nothing else. Now your battery, you have inside some sensors. So it sends a certain known current and it measures the voltage or the potential difference directly. That's why you don't see the measuring tools. This does the work for you.
The polarity of the connection is not important since the resistor does not have a polarity. So if you're connected the opposite direction, it doesn't really matter. Okay. Whenever you start your document, I will do it in a moment, a current will be sent to your board.
Let me show you the results and the explanation. You can watch them later.
You see a linear curve happening. By the way, this is voltage as a function of current again. And the output is an alternating output, so you can see.
Okay, let me explain. Do you actually see that it's going up and down?
Positive, negative, or zero.
All right, it's very important, and this is the difficult part. The students don't understand that the generator you have is sinusoidal. What do I mean by sinusoidal? You will have voltages here in the first table that would go from 0 volt up to 5 volts down to negative 5 volts. So for me to vary the voltage, I need a variable generator. And here I have the choice. I can have a sinusoidal, a triangular, anything I want. So I've picked sinusoidal and I picked a certain frequency that should not matter. Frequency is only to tell you how fast the variation is happening, you know? So in your case, you just need to understand that the voltage, and you can see it on the graph, has some positive values, some negative values, but either ways, it's always proportional to the current. That's why you have a straight line, you see? So I'm gonna take the smart tool and give you some coordinates from that point, from that line. Now let me move to the bulb. So like here, I'm doing resistor 2. You can see a change in slope. The slope is steeper. And then I'm gonna repeat on the bulb. And I'm gonna show you I'm showing you here how I'm changing my generator from 50 Hertz down to 0.3 Hertz. And this is the curve you get for the bulb at low frequency. So do you see this ohmic or non-ohmic?
This curve is for the V?
This curve is V versus I for the bulb at low frequency.
It seems ohmic, I guess. That's because there are two lines overlapping, so I can't really know which one.
So it's a curve, basically. So not ohmic. The ohmic device should give you a straight line, right? Okay, and I wanted you to see some observation on the board. This is for high frequency. So it starts, maybe I should show you the video because it starts, check.
I will hide the signal generator and record again. I will get this shape.
Okay, it was fast actually. It started with a line with low slope and then ended up with a high slope. But this is linear. Like you will see pink, very dark pink in this region, it's a line. So at high frequency, the bulb is acting like an ohmic device. And you can see the first few seconds, you have a low slope and later on you had a high slope. You have to think about why this happened and discuss it in your lab report. What I find interesting is observation on the bulb. Look.
What does this shape say?
Okay, let me show you the bulb because it's really nice to observe how the brightness of the bulb is behaving, and maybe this will give you insight on why it's acting like an ohmic device or not.
So again, this is a good view of your board. I want you please to focus on the bulb. The bulb is switched off. Yes. I will take my signal generator and make sure that the frequency is back to 0.3 Hertz, back to when it gave me this weird shape. I will start recording. I want you to notice that the brightness of the bulb varies. It will go on and off, on and off. Slowly, the frequency is 0.3 hertz, so it does it 0.3 times per second, or maybe 3 times every, I don't know how many seconds, you know? It's 1/3. So every 3 seconds, it does only one, it goes on only one time. So it's a very small frequency. That's why you see it very slowly going on and off. And at the same time, you get this weird shape that you saw on the voltage versus current.
So try to use this observation in your understanding of why the graph is acting as such. Now look at high frequency.
I will stop recording. I will go back to my signal generator. I will change the frequency to 50 hertz. And I will start recording again. Notice that the brightness of the bulb is somehow constant. Some would say that it will go on and off so fast, frequency 50 hertz, meaning 50 times per second, that cannot be seen in the naked eye. I don't know on the video if you see any fluttering, any variation in the brightness, but using my naked eye, I see no variation in the brightness whatsoever.
Okay, think about this one, all right? So I will definitely send you the link for the video so you can watch it all slowly while you fill in the lab report. So you will have some questions related to the bulb. What would be the shape? Explain why. So maybe you need to do some reading about the behavior of the bulb to be able to answer those, okay? But overall, this lab report could be done in like less than 1 hour. It's very easy, unlike lab number 2. All right, I'm done. I know I don't need to keep you longer. Maybe if you want us to stay, we can do a quick practice on how to find the RMS, but we need to do that on a calculator. So I'd rather maybe ask you to watch the video, or maybe make another video for you if you need help in this one. Okay, because using Excel to find RMS is not actually possible. Okay, so I'm gonna stop recording and I'm gonna stay if you guys have any extra questions. I wanted us to have